Thanks all. If you're still wondering who I am, I'm actually Maruthi from ClickHouse. I'm a solution architect. Thanks, Martha. So we're going to switch back into observability. I just realized when I was preparing for this session, okay, observability is going to be one of the least favorite topics, but seems like pretty much everyone lined up today is going to be talking about observability. So I'm pretty excited. So without further ado, I'm going to just quickly get started. Always starting off with ClickHouse is a database, but then what are we doing within the observability space? So we wanted to start asking those questions, but before that, we started looking at who are using ClickHouse for observability. Alexia already spoiled it a bit, starting with most of the famous AI companies out there that are using ClickHouse, like OpenAI, Anthropic, and also a lot of other large companies like Tesla. They're using ClickHouse and they're trusting ClickHouse for solving age-old problems which existed in observability. And Canva, a friend from Canva actually went through that in really good details of the challenges they face and how are they solving it using ClickHouse itself. So we were further questioning into why people are trusting ClickHouse for their observability challenges, because observability, there's a lot of tooling that's already available, a lot of out-of-the-box solutions that exist. So we really went back in time, very similar to what Martha did going back in the early stages of internet. When we started looking at, the first step is it had really humble beginnings, really looking at using just plain grep on text files to identify singular events, like why did this particular button didn't work when we actually clicked on it. So we started using grep, single boxes, single applications was pretty straightforward, but as we started really building a lot more applications and scaling it out slowly, grep was not enough. How many files can you grep and pipe and figure out what are the different events that happen to figure out what's going wrong? So that's where we started seeing companies like Splunk, like enterprise out-of-the-box solution, which helps you collect all these logs and look through them pretty efficiently. But then we didn't really stop there. We actually started still scaling out and adding a lot more applications and tracking a lot more information. So then Elasticsearch came into play. Throw in all your data. Don't worry about what structure and everything. We're going to make it simple for searching. But then one of the biggest challenges is when you have a massive infrastructure and a lot of different applications running, just looking at singular events will not help. So that's when there was another thread that spin up where we actually started looking at metrics of at a higher level. Is this particular event or this particular error, is it caused by, for example, a network blockage? Is it timing out because of an I/O issue? So we started capturing metrics from all your different services as big as possible. It started off with Graphite, and very similar to logs, as we started scaling out our system and we had more data volume and higher cardinality that's kicking in, we evolved from Graphite, moving into Prometheus, and then now more into Thanos. So these are the two main threads that's running. So with this, one of the bigger challenges was we ended up having two different sets of data stores. One really specializing in search engines, where it's more like a needle in a haystack query, like doing a grep. I want to find a particular error from a particular application. Maybe if you're smart enough, you'll write a really complex grep query on retrieving a particular timestamp. It was really great using search engines because it's really simplified natural language querying or something like Lucene to quickly query out your data. But you still need to figure out what's causing it. So zooming in, now we need to zoom out to figure out what's causing this issue. So then we need to switch back into something like a metrics engine, where a metric data store, where it's really great for aggregating large volumes of data. I'm really sorry, I didn't realize my slides were moving around. I was not actually clicking it. All right. Guys, I'm not moving it, sir. So you see, this is the slide I was trying to talk about, where we still were having two different data stores for solving a single problem. So it's you switching back into different querying languages or different interfaces, trying to navigate through. But all of this is coming from a single application, a single infrastructure that you own. So it's always between taking a trade-off between, am I going to focus a lot more on my searches or a lot more on aggregation-related queries? So that's when we were why customers are looking into ClickHouse. That's why we started adding these question marks. We wanted to add a quiz to it, but since you already know the answer to it, we're going to skip through that and give everyone a swag while you exit. Yeah, it's actually ClickHouse. The reason behind why ClickHouse is being widely used is for observability use cases is, as we saw, there's search engine type of queries, which is kind of like a point lookup in your massive data set. On the other side is really aggregating, doing roll-ups at different time, like over time. We should be able to bring those two together. So for ClickHouse itself, we have very lightweight indexes that helps us go through billions of records and search through your text in many different ways. Like Bloom filter is one of those options. And we actually have a lot more different new feature that's coming up as well, which is currently in experimental. And being a columnar store, doing aggregation is like our bread and butter. So now you can combine both your logs and metrics data into a single store and able to serve it as efficiently as possible. So going in deeper, it's what are the different features that's required? Because ClickHouse, again, is a database. And as everyone mentioned, it's like SQL first. You don't really need to learn a new language trying to figure out how do I efficiently access and work with this data that I've already collected. The next part is how do I bring in data as efficiently as possible, massive scale, because observability is kind of considered the digital exhaust of the whole digital ecosystem. So I have so much data, but so little value that you can actually extract out of it if you're not able to manage it properly. You're going to spend a lot of money. So great example was Tesla, because they ran a stress test on ClickHouse just to see out how far we can actually scale and work. So it was about 100 billion, well, actually 1 billion records over 11 days, like did nonstop, and it actually reached 1 quadrillion records. And all of that happened in a single table. It's not just a single cluster or a single database, it's a single table. So we're able to handle really large scale data ingestion throughput without having to really lose an arm and a leg. The other part is how do you store all this massive amounts of data? So we kind of eat our own dog food. So ClickHouse uses ClickHouse to do our observability for all our customers across the world. So it's called Loghouse. About 6 months ago when I looked into it, it's about 100 petabytes of uncompressed data. After compression at storage is about 5.6, 5.7 petabytes. That's almost about 19% or X compression of your overall data. And we're kind of serving it for thousands of users. So if you're a ClickHouse Cloud user, now you go into your dashboards, start looking into your query insights, your advanced metrics. All of that is being served from Loghouse. So it's kind of like large-scale ingestion, efficiently stored, and also we are able to serve to thousands of users. Becomes a very critical point for observability solution. Apart from that, we also have, as an open source company, a lot of different integrations which allows you to bring in data across the board. So again, why ClickHouse for observability? Because what we spoke about is purely a data store. We still need to figure out how do we bring in data efficiently and also kind of send data out to users to consume it as effectively as possible. That's when we thought about building this whole stack, and we named it ClickStack. And Alexi was definitely not involved in naming this, because ClickStack is made up of 3 different items. Upstream, where all information is actually being generated, we kind of use OpenTelemetry. OpenTelemetry or OTel is getting more and more popular, where it helps users acquire data from different systems. It can be your servers, it can be your edge devices, or it can be your applications. We have pre-built connectors OTel actually provides, which simplifies data acquisition into your data store. The other part is after collecting and storing all this data, we need to be able to deliver this to users as effectively as possible, because you're going to be looking at billions of data points and try to make sense of it, and you don't really have a lot of time to spend to figure out what's happening. So that's when HyperDX comes into play, where it has a beautiful intuitive UI, which lets users go through all the information from a single pane of view across any number of applications or any number of infrastructure. So I wanted to do a live demo today, but really the demo gods told me this morning, I'm not going to be supporting you, so I took a recorded video of that HyperDX, where we're going to go through kind of a scenario where it's an e-commerce application where the user has gone into selecting their favorite furnitures and everything. They want to click buy. They're ready to buy, but the purchase button is actually failing. So then the engineers called SRE is going to investigate the whole system, where they actually simply start looking at logs, like what are the error logs that's happening. And as you can clearly see, it's like a beautiful UI, very intuitive for you to like scan through, because now we have thousands, or this is few hundred million queries, and as you can see, like we just identified very easily logs and then what's happening and isolated something. And now switching back from logs to metrics, we're gonna get into metrics, where you start seeing at an aggregated like point of view what happened during that point in time. And then we didn't really stop there, because logs and metrics is just the beginning for observability. You need to get into traces and spans, where you're really naturally progressing from a zoomed in view, zooming out and trying to navigate your whole infrastructure ecosystem to figure out what really caused this particular button not to work. So as you can clearly see, we just continue to like really intuitively navigate. We're not trying to switch screens, trying to go across multiple applications, taking a note of your timestamps or whatnot from in your notebook. It gives you this natural flow from start to end to figure out. Either it can be a zoomed in view or a zoomed out view. It can be your network issue or even your application failing, timing out. It gives you a very simple way to access your data. So this is kind of like towards the end, where like we kind of figure out it's not related to something that we thought either an infrastructure issue or an application issue. This was purely into a particular cache for a Visa payment processing that's happening within your application. So that cache being overflowing stops the user from clicking a button. So kind of like provides you a really good intuitive view. This is also my favorite part, because now you want to further navigate and investigate to that one particular issue and to see, has it happened previously? Is it the first time they're noticing it? So this gives us a really good view now, combining your logs, traces, and metrics, and being able to visualize it over a period of time. So as you can see, the cache hit the maximum load, and anything after that, every single button clicks or events got dropped, because the whole cache was full and the system is trying to evict it. And before the eviction, any kind of events fails. So ClickStack has been there for about a couple of months now. So just wanted to quickly cover like one of our early users. So Character AI is a generative AI company specializing in kind of generating interactive entertainment content. So they were having a couple of common challenges that most customers face with observability. They were not able to capture enough data, and they were not able to query them fast enough to solve problems, and it was really expensive for them to maintain the system. So as an early adopter of ClickStack, they started looking at now from just storing a couple of weeks of data, they are storing about 3 to 4 months of data. And their queries, which took like upwards of 10 minutes, now they are happening within a couple of seconds. So what this means is now they are able to look through larger durations for better pattern understanding of, is it a recurring event or is this a one-off anomaly that's happening? At the same time, they don't need to wait for 30, 40 minutes to figure out or narrow down into an event. It takes a couple of seconds to figure out where this issue is happening. The last and most important part is the cost. Even with all this increased workloads, better performance, they actually started saving 50% of the cost. So that's kind of like the overall efficiency that not just with ClickHouse, but the whole ClickStack can offer out of the box for users. What's new? Like, as I said, we have been having ClickStack for a couple of months now out in the market, and we kind of talk to our customers and users to understand what else is missing. And we started looking into further optimization. So a friend at Canva was talking about maps, but then we have introduced native JSON data type, where like it's kind of schema-less, where kind of bringing in all your different technology stack into the same place, kind of putting it into the same table so you can have a cross-plane view of all the information. The other part is inverted index. Is currently an experimental feature. This is the upgrade to our Bloom filter search. So if you want to do natural language search, Bloom filters and inverted index is going to improve the overall performance and efficiency of the system. And the last part is really diving into observability as a use case, like what do the end users, like a site reliability engineer, what do they need? when using ClickStack, so further improvements. And there's a lot more features that's being developed. Like a couple of my favorite features are the CSV export. Even though there's a beautiful interface, I still, at the end of the day, want to export the logs. And these days, I actually export the CSV file and just throw it into Cloud. So I don't want to go through manually and do my pivot tables and then. And the other part is the inverted index, which of course is really going to improve a lot of the user experience working on HyperDX itself. Apart from that, we also have a really exciting roadmap planned out for observability. So starting with PromQL. SQL works great, but a lot of the users still really love Prometheus and PromQL. So we kind of added this native support. So the translation will happen naturally within ClickHouse. So write in your PromQL queries. If you're migrating from a system which uses PromQL, this simplifies your work. And the exciting feature for me is the observability notebooks, which is very similar to your Python notebooks are similar to that, where like instead of you just doing a simple analysis, now you can go into a deep dive investigation, build a whole workflow, and then you're going to be able to share and collaborate with your colleagues. So it gives you a really strong interface within HyperDX, which kind of like lets you scale out your systems. You can actually get started with this today. So the whole stack is fully open source, and also there's a cloud version that's up and running. So for the open source version, you can just pull a single Docker container and get started now on your systems. For the cloud, we're making a lot of new changes. So you can just go into play-clickstack.clickhouse.com, and you should be able to get through the HyperDX interface and the demo I just showed. Thank you very much. I'm going to actually invite my soon-to-be best buddy, James, onto the stage to share more about what they're doing at Laravel.